APC, automated parking operation. What we do is we manufacture and sell automated parking systems. So what I will be doing is presenting how these automated parking systems integrate very easily and actually are a necessary part of a smart city. The automated parking system needs to be seen as a system that is already integrated. It's because it's a robot, it's a machine, it's not a building. So it's naturally integrated or integratable to any smart structure, any smart city or university, however you want to integrate. So for probably people that are not very familiar with this technology, we prepared this little video that showcases the industry, not just our systems, but the industry at large. That's an industry overview. You saw some systems that are very high-tech. There are systems that are much lower tech. All of these systems are controlled by a PLC. And this is probably the most important part of this presentation today. So when you need to create data and to recollect data, in a traditional parking, you need to adapt a system. You need to get sensors, you need to create some type of way to help the people move around and understand where their car is supposed to be. In all of our systems, the systems are controlled by a PLC. I don't know if you're familiar with a PLC, but it's a programmable logic controller. So this allows for many advantages. Not only that the people don't need to get involved in parking their own vehicle, but that you have and you create all the data that you might need to adjust the usage. Or let's say in a university, you can have an automated parking system that is used by the public. And at one point, you decide to devote it to be used by faculty. And in a sporting event, you want to make the system available just for anybody coming to the event. So all of these changes can be done over software in these machines, not on anything physical. The levels of integration. Automated parking systems are already level number 4, that is fully integrated intelligent infrastructure. At the end of the day, even the systems is not that they're going to keep that level of intelligence at that level forever. Yes, the mechanical parts are going to remain as they were designed and installed day one, but as technology evolves, we can adjust the control system for this type of system, this type of machines. So, connectivity and big data are intrinsic to these systems. Collecting, processing data, it's something that is done just at a software level. This is just a picture to showcase the challenge of governance. How do you manage a traditional parking system? It doesn't matter if it's just a surface lot or if it's a multi-level garage. When you need to have some type of security personnel to move around, it's complicated. When you need to get enforcement, where is the people going to be parking? If you want certain people to park in the area that will take longer for the car to be retrieved, you need to have physical person moving some type of public or part of the parking lot, and some other people, VIPs, to another part of the parking lot. This, for governance, for us is very, very easy. It's just a part of the ticket that people will have certain privilege or don't have them. This is just like a bullet point list that whoever wants this PowerPoint, you can have it, and you'll have all the little details that I don't want to bore everybody going over every little detail. But I think you're getting the point. Smart mobility, the advanced parking that every smart city is looking for, we already do it. We say that you arrive, park, you are done. You don't need to go through the system, walk, take elevators, you don't need to do any of that. You are always parking in the best station, the ground floor, in the first parking space. It doesn't matter if your car will end up, whatever, 10 levels up, the position where you park your car and where you retrieve it, it's always on the ground floor, the easiest position. Also, there is more time for people to do whatever they need to do, instead of driving through ramps, looking for space, wondering if they're going to have a space or not. The fact that we can have mobile apps managing these machines allow also for a pre-selection of a parking space. Let's say that you are driving to whatever meeting, and you realize that in that parking facility that you are planning to park, there are only 5 available spaces. You have the opportunity at that point to buy that parking space at that moment. So you have the parking space, you are paying for it, whoever is invested in buying that parking, building that parking, is collecting revenue, but you're not still there. But now you are 100% sure that you're going to have parking when you arrive. This also allows for something that we call in-field development. Usually in a traditional city, when you need more parking, you're going to have to develop a big chunk of land because you need certain geometry for ramps to have the proper dimensions to comply with design constraints. So you cannot have almost infinitely smaller parking system. With this technology, you can do infill. Instead of moving at the edge of a city and creating the 1,000 parking spaces that that city needs in order to function, you can use the little available pieces of land that are still available or they are underperforming for whatever reason, and have much smaller, much denser machines spread around the cities, just doing infill. And that creates another advantage, which is that most urban planners are going to tell you that people don't walk more than 200 yards. That's it. That's as far as we are willing to walk, because otherwise we are going to get sweaty if we are in a hot weather, or we're going to get snow or rain. And nobody wants to walk beyond these 200 yards. So if you have in a given city the necessary 1,000 parking spaces at the edge of the city, then whoever needs to go 5 blocks away from that parking needs to walk. With infill, you can use the little available spaces, and everybody's going to be able to park very close to the place they are trying to go. Another interesting thing is traffic intelligence. And these machines, you can regulate how much traffic are you allowing to get to the streets. We did a study for a hospital in Puerto Rico, and we had to stop the machines from delivering cars because the traffic lights couldn't take it. If you use this type of technology, you can interface the traffic lights with the machines, so the amount of cars that are given to the streets are the amount of cars that the street can take. Smart environment. It's easy for me to explain why these things are extremely green. First, are light. So usually, if you build conventional concrete ramp garage, you're going to have 10 times the weight of the vehicles that you're parking in that given ramp, in that given garage. So when you have all that concrete, it's a heat sink. So in cities like here in South Florida, that building is collecting heat. And when the sun goes away, it releases that heat back to the city. That creates a process that is called heat island effect. And it's a big thing, and the denser the cities become, the worse that's going to be. We, instead of weighing 10 times what the amount of cars parked weigh, we weigh 50% of what those cars weigh. So we are 20 times lighter, less massive. So we are 20 times less capable of accumulating heat. Anybody who's dealing with lead and is trying to see how to control this in the city, the heat island effect, this could be one of the components to help with the heat island effect. All the other values that you see in this slide have to do with no driving through ramps. So you see that the building is very light and the cars somehow are there. The energy that we use to move the car up is the smallest amount of energy, because every vertical motion is counterweight, and we don't use gasoline, we use electrical power. That, if we're lucky, it's produced in an environmentally friendly way. But we use energy for probably seconds, probably a minute, because we don't need to go through ramps for whatever, a couple of minutes with a 200, 400 horsepower engine just to get to the parking space. Here we just move the car in the shortest possible, in the position where it's going to remain, and then when we need to retrieve it, gravity does the work. So there is no engine working, and this contaminants reduction comes from the National Parking Association. It's a study done in 2009. So, and most people don't even know about this fact, that it's extremely green to use these machines. Smart living. These machines can accommodate the same number of vehicles in 1/3 the cubic space. So this is a general number, probably could be closer to 50% in most cases. But in the best possible scenario, we can accommodate the same amount of cars in 1/3 the cubic space. So if we have a height limitation, we can have having the same limitation, the same height limitation that a ramp garage has. We can have 1/3 of the volume and having the same amount of cars parked there. So the rest of the space that we are freeing is available for other things. Of course, for gardens and income producing part of the property, something that has more value to the city than just parking a car. Cities like Beijing, they force you to have 80 or 70% of automated parking system in the new buildings in certain areas of the city, because the government don't care about parking cars and using their valuable land just to park cars. They allow you to remember, I think it's 20%, something like that, for traditional ramp access, and the rest must be with an automated parking system. This website, BJS, it's a Bureau of Justice Statistics. And you can find there the amount of crime that happens in garages, because people are vulnerable in parking garages. So, and they even have money value, depending on the city. How much is costing the city the crimes that are happening in garages where people cannot defend themselves? All these automated parking systems, nobody needs to be inside of a parking garage, a poorly lit thing, walking in the middle of the night. You just call for your vehicle is going to be there waiting for you, and get out, you get up and leave. And you're already protected. And even if you use personnel to protect that parking garage, that personnel can be 100% looking at the area where the people are getting into their vehicles. In cities where you don't want to demolish half the city, you can have integrated small systems in buildings that probably don't have value to be refurbished and reused, but you can keep the front of that particular historic building and have another use in the back, just with one of these machines. Smart economy. We reduce costs. These systems usually cost or the same or less than a traditional concrete ramp garage. But that's just one little part of the equation, because that is only if you consider the cost of the machine or the parking space. If you take into account the amount of land that you're using and the tributary impact, the tax cost of having that much land devoted just to parking, then we are always a lot cheaper than traditional parking garages, because we use less land. Not only that, these systems go up fast, very fast, sometimes in a couple of months instead of a year. So the disruption of the city is a lot less, because you don't have dust in the city and noise and a lot of things that you need to put up with for a full year. These systems, probably within 60 days, the system is already installed. Also for private developers, these systems are not buildings, so they go through a specific fast depreciation process, which is 7 years instead of 30. When you pile up the amount of savings that your project has just because you're using this, it's freeing up capital to do other things. Repurposable, that's another big thing. Let's say that a smart city needs to be smart today and at least in the foreseeable future. All these technologies, what they do is just move a platform of some sort. Even in a smart city that was able to function today, or in this decade, with cars, with traditional vehicles, and we have these automated parking systems being used. If, for whatever reason, cars are not going to be used in the future, we will be able to use the same machine for storage. So people might not have their own cars, but they have their nearby storage. I am part of an association that we are talking about starting to use our systems for vertical farms. Because at the end of the day, we just move a little platform. What do we do with that platform? Whatever, a couple of things, but the more people like you get involved, the more uses we might find for these spaces.